Okay, so we'll start with this K means clustering. So now here we will also see how we can make a use of PCA, that is principal component analysis. To so one this PCA is nothing but a dimensionality reduction technique, one of the technique where we can reduce the dimensions of the different multiple columns into 2D plot. So it gives you the structure into 2D graph instead of weaving into multi directions. Okay, so that is what the PCA technique which helps us. And so we'll start with this. So initially I'll explain you the data set, and then we'll move into the technique. What is the technique? Okay. So this data set is nothing but East gene expression data set. So it is
So, are we going to go through the algorithm also, or only through the code?
the algorithm, not mathematically, but the steps which we have.
Steps you mean by code?
Uh, the initially the steps and then the code.
Okay, okay, okay.
Okay.
Sorry.
Okay. So now here, this data set is little bit, I mean, towards the biological data set. So
Yes.
here, the description of the data set is like the East gene expression data with three classes. So the labels over here are nothing but protease, resp, and ribo. So these are basically gene functions after expression. So the size for the data which we have here is 186 rows. That is nothing but a different genes and 81 columns. So out of 81, 79 contains the gene expression of Baker East in various conditions. So the particular gene is expressed in 79 different conditions, and finally, depending upon this expression, it gives a gene function. Okay, and we have one more column called as a meta attribute, which provides a name to the gene, and one column is nothing but a class, or you can say the label, which is nothing but a gene function. Okay, so this is what the data is all about. Okay, now while considering this data for clustering, we are not going to consider the label thing. Okay, so we will consider only the features. That is nothing but a gene expressions, like 79 column. Okay, and in clustering, so in clustering, there's no label, or you can say that there's no y, only we pass x to the algorithm, and it gives different clusters, basically depending upon the features, or you can say the correlations uh, between the data points. Okay, so that is what with the clustering. Okay, now, with this problem statement, what we have is, with this data, whatever data we have, we address the problem of finding the structure of the data given just the features. So we pass. So again, over here, we will just bifurcate the data into two parts, like X and Y. So here X is nothing but a expressions, gene expression, and the Y means our label. But for the algorithm, we consider only X, like the gene expressions. Okay, and we will see whether it is finding a good result. I mean, the accuracy. Okay, since we cannot visualize beyond 3D, we will use a technique called as principal component analysis. As you can say, we can either view only first two columns, or either two columns or three column maximum. Okay, but to visualize the whole data uh, over here is not possible. For that, we will use a principal component analysis, which reduces the dimension of the data. Okay, so that we will discuss over here. Okay. And then we will use or we can apply the k-means algorithm, which is an unsupervised technique. Okay, and then we find out the clusters within the data. Okay, so we'll first discuss on the principal component analysis. So this technique is basically used to reduce the dimensions. So here we will just explore the data structures. We are not getting any. It is just for visualization purpose,
Mm-hmm.
how the data is correlated and how it look like. Okay, so just explore the data structure, visualize the high dimensional data, and
Mm-hmm.
pre-process the data for the use of in the other algorithms. Okay, that is the role of this. I can say the PCA. So PCA plot converts the correlation between the different columns into uh, 2D graph basically. Okay, so that and columns. I mean, it correlates columns that are highly correlated uh, into one cluster. So the columns which are highly correlated into one cluster, then next correlation likewise. So it gives the number of clusters depend within the data. That is what with the PCA. Okay. Now the algorithm is like that. The PCA we can summarize into three steps. So first step is nothing but a normalize the features. So that is converting into a range, one range. Next is find the principal component of the features like PC1, PC2, like depending upon the 2D plots. And then select the top feature that help to visualize and understand the patterns in the data. So these are the three steps. Uh,
Okay.
there are a lot of mathematic or eigenvalue, eigenvector is behind this that I am not going to cover over here. So these are the basic steps we have. I'll show you the result after using this principal component analysis.
PCA mathematics, I understand. I think I have done enough PCA work, not in machine learning though,
Okay.
but wherever we had a the dimensional reduction issues in our,
Okay.
because we work on images, no.
Okay.
So there are enough places where we have to use it.
Yeah.
So it should be fine. So
Okay.
mathematics,
Okay. So
yeah.
there's one more technique called as TSNE also plot. That is also helpful to, you know,
What is that?
that technique is T hyphen SNE. So
Okay,
that
that
is
I
one
haven't.
of the plot
Okay.
which is basically used for plot the image data into multiple this thing. I
Mm-hmm.
have one more plot. I have one plot. I'll show you that how it look like.
Okay.
Okay. So that is also a dimensional reduction technique
Okay.
like PCA. Okay. Now this principle we will apply now this principal component analysis on this data set over here. So we'll just first we'll just load the data set as and then we just try to plot it. Okay.
Mm-hmm.
So here we have the data set. The name is brown hyphen selected CSV, and this data set look like this. So there are 81 columns. This is nothing but a name of the gene, and these are the different expressions, or you can say the conditions where the gene is expressing. Okay,
Mm-hmm.
and finally, after expression, it gives a gene function. So for
Mm-hmm.
this first row, the protease is the gene function. Okay. Now, if you observe, there are some null values, we can say
Nan values.
nan values. Okay, so we can fill up those using this function. So data dot fill nan by data mean.
Of that
Okay,
data. Okay.
okay, and it gives you the accurate. I mean this data. Now we will see how many data for or the data points for each functions. So here you can see for ribo there are 120 records, protease 35, and the rest 30. This we can get using the last column dot value count. Okay,
Mm-hmm.
same thing we will visualize over here using this plot, bar plot.
Okay.
Now, here we don't want this gene function as well as the last column,
Yeah.
like the label. So we will just drop those two things, column one, okay? And the remaining is nothing but our all the features, which
Yeah.
we are going to use to for further things, okay? Now, this selecting the target from the data. So we will select Y. which we will use for just testing purpose, not just training. Okay, so we will only pass this X to the algorithm. Now, how we'll apply this PCA technique over here? So this PCA is imported over here. So sklearn dot decomposition import PCA as sklearn PCA. Now here we need to mention the components, whether it is 2D or 3D. So PCA is equal to sklearn. We'll pass n components to this, and then we will just transform it over here. So like this pan dot data frame is equal to the PCA dot fit transform, and we'll just pass this features.
So
And
what
this is
what does
nothing.
it do, by the way? When you say transform, what is it doing exactly? Fit transform.
Uh, we have the X values, right? X are nothing but multiple features. Okay,
Yeah,
we are converting those multi columns into
in two
two
groups.
columns. Okay,
Okay, got it.
uh, for so mathematically just correlate, and the with the higher features it gives two columns over here. So 0 and 1. These are
Okay,
highly correlated. Okay,
okay,
then how we will visualize this? So these are the two columns which we can easily visualize with the help of this plot. Okay, so this plot gives you three different clusters. Okay,
so
so
what
this
loss
is not
happen?
actually the clustering algorithm we applied. We have just transformed the data into two columns, and we have plotted over here as it
Yeah,
is.
how did
Okay,
we plot? Can you just go up?
yeah, so I'll show you. So
Okay.
these are the transformed data. So just by applying some I mean this logic. So
So you have taken the first column only, zeroth column.
yeah, yeah, over here, and this is what the
White
one.
column on the other side, and you have plotted. Okay.
Yeah, and we have just assigned over here some colors like red,
Yeah, that's
just
fine.
for simplicity.
What is here?
Okay, so these are the different. So this is just for representation, and this is not a
Yeah,
cluster.
got it, got it, got it.
So from this plot, we can say that there are see now in clustering algorithm we need to fix some clusters, maybe two or three, how many clusters you want to clusterize the data. Okay,
Correct.
so from this initially if we apply this reduction technique, and if you observe that there are three groups or two groups are there, then we can easily pass those cluster to the clustering algorithm. Okay,
Correct.
so we will just now move towards clustering algorithm k-means. Now we'll see whether k-means clustering is plotting again, like, or you can say that gives a similar structure over the
Yeah.
prediction. Okay, so now here we will so one of the k-means clustering is one of the unsupervised technique or of clustering, which deals with the finding structure in a collection of unlabeled data. Okay,
Yeah.
so in over here we are not considering the y. Okay, so clustering, this process is organizing the objects into groups whose members are similar in some way, like in terms of features. Okay,
Okay.
now these are the possible applications where we can apply within marketing, biology, data, and libraries, insurance, financial thing, city planning, in websites, to document classification. And okay, so these are the possible applications. So this is the algorithm. I have some animation over here. So just pick up the initial centroid. So step one. So we'll just go with the steps.
Okay.
So now it works like this. So first we choose a key. Key is nothing but the number of clusters we want to find within the data. Okay, then the centers of those clusters called as centroids. Okay, so we have suppose we have the data set, and we will just assign the centroids or initialize in a some fashion. Okay, so now this I'll choose over here uniform. So these are the basically data point. We will say 3 clusters. So we'll just as randomly assign this thing clusters. Okay, so we have we want to find 3 clusters within this data point, and here we have assigned some points called as centroids to these clusters. Okay, now in the reassign points step, we assign every point in the data to the cluster whose centroid is nearest to it.
It came up. Yeah.
Okay, okay. So now here the points are not assigned to particular centroid. These points are assigned based on the distance between the point data points and the minimum distance between the data point and the centroid. Okay, so we'll just assign the point. So if you consider this point, then the nearest point, depending upon the Euclidean distance formula, it calculate the distance, and the nearest data point will assign to this centroid. Okay. Now this centroid is not again say at the center of the particular data set. If you consider this green, this centroid is not at the center of the data point, this green data point. Okay, then we can say that update the centroid. So here we will take a mean of the every data point distance with the centroid, and we will just relocate that centroids over here. So
Yeah.
now you can say that these are the this green dot is at center of this data set. Okay, now again reassign the point because these are the shuffle all the, so we'll just reassign the point. So this continue till at specific stage uh, where you can say that the stopping condition. So in the update centroid step, we recalculate each centroid location as the mean of the of all the data points assigned to this cluster.
Yeah.
And uh, then we'll iterate this step until the centroid stop moving. Equivalently, we can put the some stopping conditions on this. So this is what the simple explanation over here. Now we will see how we can apply this to our data set. So this k-means is now again into the sklearn library. So we can say from sklearn.cluster import k-mean. Okay. Now here we have to pass the number of clusters. Okay. So here we can say that k means n cluster is equal to 3. We observed the data with the help of the PCA or any dimension reduction technique, and we observed that there are 3 different clusters, not specifically ribose and this thing. We have observed 3 different clusters, and we will just create over here a model. So model dot fit x. Okay. So this model gives you some labels,
Yeah.
whether it is 1, 0, or 2, depending upon the cluster points. Okay. So we will compare. I mean, with clustering, we cannot just check the accuracy. So I'm just comparing for our reference. So
Yeah.
here model dot label underscore. This is what the trained by this model, this
Correct.
variable. Okay, and this is what the output. Okay, and we have with us y. Okay,
Yeah.
but this y is in string base. We'll convert it into numbers and we'll just compare these two things. Okay.
Yes.
Okay, so we return some this function where wherever x is equal to Proteus, we just replace with 1 simultaneously. So this function applied on this y column over here, and which gives you wherever Proteus, just replace 1. Now this trans function is I'm going to compare with this models label,
Yeah,
just to
yeah,
observe the accuracy. Okay,
yeah.
so here you can say that here I am using transform, which is from the plot from original classification, like a
Yes,
PCA from PCA, and
yes,
this is from the k-means. Okay,
correct.
and this you can see that from PC. I mean, this is from PC and this is from k-means. If you observe here, this three blue dots from this blue cluster. Now,
Correct.
due to the clustering, this converted into this RESP.
So basically, you mean K-means is better than PCA?
Uh, no, no, PCA is just a visualization technique.
Yes, yes. But in some sense, it also tried to cluster no things differently, right?
No,
Yeah.
so basically, this is not any algorithm. This is just a
Got
visualization. Whatever data we have, we are going to put into dimensions, 2 dimensions,
correct,
and
correct,
it is visible. Now, this k-means clustering gives you a clusters.
correct.
Okay, so these are the three clusters, and somewhere we have just I mean, this colors are again managed.
Got
Okay,
it, got it, got it. Yeah,
okay,
that's okay. That's okay.
and these are the colors.
You just need to make blue as red and green and red
Yeah,
as
yeah,
blue.
yeah,
That's
yeah.
okay. That's
Yes,
okay. No
it
problem.
is. So this is what the k-means clustering, where we can.
Okay.